in problem 46, we're still solving for variables. The first thing that we want to focus on here is on finding W, and W is confined to this triangle. We have a 45-degree angle there and a 90-degree angle, which means this other angle has to be 45. And since you have two congruent angles, their opposite sides are congruent, which means that W is 160. Now, if I erase all this stuff, now we can focus on how to find Z. And for Z, we want to focus on the whole triangle. And that whole triangle, we no longer have the 45-degree angle. Now where Z is, we have a 30-degree angle, a 90-degree angle, which means this whole thing here is 60 degrees. So 160 has become our short side. And to go from short side to long side, we have to multiply by the square root of 3. So that whole thing is 160 square root of 3. But we've already used 160 for W. Now you can't just subtract 160 square root of 3 minus 160 and say, hey, it's the square root of 3. It doesn't work that way. So we need a decimal answer for 160 square root of 3, which is 277.13 approximately. And we're going to subtract 160 from that. So for Z, we get 117.13. For 47, again, we have two different triangles. We have a 45, 45, 90, and we have a 30, 60, 90. Now, the 9 square root of 3 is with that top triangle there. So we want to find this side of the 30, 60, 90 triangle. Now, to go from our long side to our short side, we can divide by the square root of 3, which means it just cancels out. So we get 9 here. And then to go from short side to hypotenuse, we just times by 2. So 9 times 2 is 18. And now to find x, we have to take 18 and we have to divide it by the square root of 2, which means we're multiplying the top and the bottom by the square root of 2. So 18 times the square root of 2 is 18 square root of 2. Square root of 2 times square root of 2 is just 2. So we get 9 square root of 2. There's our answer. Now, if you forget those shortcuts for 45, 45, 90, and for 30, 60, 90, you can always use trig. So we would start with the 60-degree angle, and we have our opposite side over our adjacent. So we'd have to use tangent to find that bit, or you could kind of cut off that step by doing opposite over hypotenuse. So you're going to do sine of 60 equals 9 square root of 3 over x and solve for x. And then when you get to your 45, you can go ahead and you can do trig again. You have adjacent over hypotenuse. All right. Those trig formulas are given to you. The shortcuts are not given to you, but the shortcuts do save you time. So they're still worth knowing. Now, if we take a look at 48, we have a big overall triangle with a 30-degree angle, which means we have a 30, 60, 90 triangle here. And then from there, we can go from hypotenuse to short side by dividing by 2, so this is 50. And now we found one side of our smaller triangle. So let me erase the rest of this, and let's focus on the smaller triangle. We have a 58-degree angle, which means we can't use our shortcuts for 30, 60, 90, and 45, 45, 90. Now we have to use trig. So we have opposite over adjacent So that one is going to be tangent. So tangent of 58 equals 50 over x. We have to multiply by x first, and then we'd end up dividing by tangent of 58. So I'm just going to write what you end up with. So when you multiply both sides by x, you get x times tangent of 58 equals 50. Then you have to divide by tangent of 58. So you get x equals 50 divided by tangent 58. Right? That you can plug in to your calculator. So let's see what we get here. We get 50 divided by tangent 58. And when I plug that in, I get 31.24 or 31.2, I can say is my answer. For problem 49, we have, first we have some parallel lines, which means if this angle down here is 90, we know this guy up here is going to be 90 because they're same side interior, which means they're supplementary. And then we can take a look at how we can go ahead and solve for some of this. If we draw a line here and make a rectangle, right? This piece here is 4. I'm going to go over my y here real quick. This is 6. Right? And you can, again, use your 45, 45, 90 knowledge to know that, well, if that's 4, then the bottom part is 4. And to find x, we just have to take 4 times the square root of 2, and we get 4 square root of 2. And then, to find y, I know I drew on top of it, y is the entire thing. So y is this entire side here, which means we're just adding 4 plus 6, so y is 10. There's our answer. The next section is to determine if a triangle with the following sides is acute, right, or obtuse. Now this you have to take into account your a squared plus b squared equals c squared. Okay? I'm not going to write out the whole thing due to lack of space, but I will write out what you should be seeing here. So if this is a, this is b, and this is c, a squared is 144, because it's 12 squared, plus b is also 12 squared, so also 144. And I don't want to write equals. I'm just going to leave it. And 15 is 225. Okay. Now 144 plus 144 is 288. And 288 is bigger than 225. So if a squared plus b squared is bigger than c squared, then this triangle here would be acute. All right. Now, we want to deal with b. Our biggest side has to be c, so ABC here. And then a squared is 7 squared, so 7 squared is 49, plus 49. And 12 squared is 144. So this becomes 98, which is less than 144. So this guy, since c squared is bigger, is obtuse. And then for C, our last one here, 15 can be A, 20 can be B, 25 can be C. So 15 squared is 225. 20 squared is 400. 25 squared is 625. So we get 625 on this side equals 625, which means C is right.